So this video is on the chapter 12 last minute review for the test. So on these problems, you have to pay attention to what interval they want. They want for all. And we want to, if you have just a sine or a sine square, nothing else, no other sine or cosine or anything, get your sine by itself. So first thing I'm going to do is I am going to add the 1. I'm going to divide by 2. I am then going to take the square root. Now, when I take the square root, I get a positive and a negative. And I take the square root of 1, which is 1, and I take the square root of 2, which is root 2. And we rationalize. We don't like it like this. So we're going to multiply top and bottom by root 2. And so I'm really trying to figure out where is my sine equal to a positive or a negative root 2 over 2. And that's all my fourths. So I'm going to be here at pi fourths, at 3 pi fourths, at 5 pi fourths, and at 7 pi fourths. Now, these are the ones where we go plus or minus, usually 2 pi n, but we want to see if we can take this and add something to get here. And that's really 2 pi fourths away. And here to here is also another 2 pi fourths and another 2 pi fourths. And here that's 1/4 and another fourth, so it's another 2 pi fourths. So I can really add 2 pi fourths onto pi fourths and get all of these. Now, my 2 pi fourths is really equal to pi halves, okay? So my answer is going to be pi fourths, and then I'm going to add and subtract 2 pi fourths, because that's what the blue is, 2 pi fourths, but 2 pi fourths is really pi halves n, and that's your answers. On number 2, similar idea, but this time pay attention. We're going from 0, including 0 to 2 pi, but not including 2 pi. And so I am going to get my cosine squared by itself. So I'm going to add 1, and then I'm going to take the square root. And so I'm going to get cosine x is equal to positive and negative, and the square root of 1 is 1. So I basically need to figure out where is my cosine x equal to 1 and where is it equal to negative 1. Okay, well, it's equal to 1 over here at 0, and it's equal to negative 1 over here at pi. And so those are my answers. My answers are going to be x is equal to 0, x is equal to pi. And again, I'm just going from 0 to 2 pi, once around the unit circle. On number 3, this one is saying for all. Now you'll notice here, I've got more than one sine. So this is not one that I try to get sine by itself, everything else on the other side. I'm going to factor this. So I want it to equal 0, which it does. Okay. So I notice I can take a sine from here and a sine from here. So I'm going to factor all the sine. And I'm going to get 2 sine x minus 1 equals 0. So I'm basically going to work out two problems. Sine x equals 0. And then here, when I take 2 sine x minus 1 set equal to 0, I'm going to get sine x is equal to 1/2. So let me start with that. My sine is my y. So I want long comma short, long short. So that's going to be pi 6. It's also going to be long short this direction, which is 5 pi 6. And if I'm looking at that, trying to go from one to the other, you see this is 4 pi 6. But visually, you can see that this is going to be a lot longer. So I can't take pi 6 and add and subtract something to get to 5 pi 6 and back. So I am going to have two separate situations here. One is going to be pi 6 plus or minus 2 pi n. And the other is 5 pi 6 plus or minus 2 pi n. Now, my sign being 0, again, sign is y, and sign is 0 up here at pi halves, and actually down here at 3 pi halves. Now, in this case, let me do it in this baby blue. When I'm going from here to here, that's the same as me going from here to here. That's their pi away. Okay, so I can write this as a single situation. I can go pi halves, and then I'm going to go plus or minus 2, sorry, not 2, pi n, because they are pi n away from each other. So I've got this, and I've got these. Those are our answers. On number 4, okay, again, you've got more than one sine or cosine here. So you don't want to get your sine by itself, for example. You need to factor. I notice there's a sine in both terms, so I'm going to get a 2 cosine x minus 1 equals 0. And then I'm going to solve this. Where does sine x equal 0? And again, that's going to be here at pi halves and at 3 pi halves. And this doesn't specify, but if they don't specify, let's assume it's for all. Okay. So this is going to be pi halves. And remember, we just talked about this on the other problem. The distance from here to here is pi, and the distance from here to here is pi. So I can go plus or minus pi. So that's one set of answers. Now for the second piece here, I'm going to do 2 cosine x minus 1 equals 0. So basically cosine x is going to be a 1/2. That's your x. So I want short long, which is going to put me at pi thirds. And down here at 5 pi thirds. Now, if I'm looking at the distance from one to the other, the distance from pi thirds to 5 pi thirds is not the same as the distance this direction. Whoops, where am I going? Hold on. Sorry. Is not the same as the distance this direction. Okay. So what does that mean? I'm going to have two separate answers here. Pi thirds plus or minus 2 pi n and 5 pi thirds plus or minus 2 pi n. And those are our answers. Okay, on number 5, okay, these ones we're verifying. I'm trying to get a cosine theta. So in this situation, what I'm going to do is I'm going to rewrite cotangent. Let me just jot it here. Cotangent theta is the same as cosine theta over sine theta. And then I'm going to also rewrite my cosecant theta. And cosecant theta is the reciprocal of sine, so 1 over sine theta. Okay, so let me write those in place of my cotangent theta and cosecant theta. So I'm going to get cosine theta over sine theta over and 1 over sine theta. And again, our goal is to get cosine theta. I can rewrite this. This is going to be cosine theta over sine theta. And when I divide by a fraction, I can multiply by its reciprocal. And then you'll notice that my sine theta and sine theta cancel out. And I end up getting cosine theta, which is what I wanted on the other side. So that worked out. On 6, so for this one, what we're going to do is we are going to try to figure out what cosine of 2a is, and it's helpful if we have our formulas. So in this situation, let me just jot down the 3 different ones we can use for this, okay? So we can write cosine of twice our angle as cosine squared minus sine squared. So cosine squared A minus sine squared A. We could also think of it as cosine 2A is equal to 1 minus 2 sine squared A. Or we can think of it as cosine 2 cosine squared A minus 1. These are the different formulas, okay, that I can use. So in this case, they're telling me it's in quadrant 3. So that means it's down here. Opposite over hypotenuse. And then if I use Pythagorean, I'm basically going to have a 25 minus 1, which is a 24. So I'm going to get a root 24, and I could take out a root 4 times a root 6 is a 2 root 6, and this would be a negative 2 root 6. Now, I can then use that to use cosine squared minus sine squared. I could use the formula 1 minus 2 sine squared, which means I didn't even have to do that because I already know my sine. Or if I wanted to, I could have used the cosine, which is negative 2 root 6 over 5. All of them are going to give you the same answer. Myself personally, I would have used this one here because I already know my sine right here. So if I want to find cosine of twice my angle A, and I know that my sine of that angle is negative 1/5, and I'm going to go 1 minus 2 times a negative 1/5 squared, which is 1 minus 2 times 1 over 25, which is 1 minus 2 over 25. And when I do that math, I get 23 over 25, and that's your answer. Okay. On 7, we want to find the exact value. So when we're doing this, cosine inverse is going to go from 0 to pi. That's the interval I'm looking at. And I want to know, where is my cosine in negative 1/2? Cosine is x, so that's short, long. I'm right here at 2 pi thirds. So that's my answer, 2 pi thirds. On 8, I got to start with what's on the inside, work my way out. So I'm first going to start with tangent of pi. And so at pi, this point is negative 1 comma 0. And so my tangent is, remember, tan is sine over cosine, or y over x. So I am going to have 0 over negative 1, which is 0. Okay. So then I want arc sine of 0. And arc sine is going to go from down here at pi halves, negative pi halves up here. So it goes from pi halves up here to negative pi halves down here. And I want where my sine is 0. And my sine is 0 here at 0. So your answer is 0, 0 readings. On 9, so we have some sum and difference formulas. This one here, when we have cosines and then sines together, that is the cosine A, cosine B, oops, forgot my S. Cosine B minus sine A, sine B. And that is equal to cosine of A, and it's always opposite of this for the cosine one, where the cosines are together, plus B. So what I'm going to do is I'm basically going to take cosine of, and I'm going to take pi 6 plus pi fourths. That's going to be cosine of, I can make these both 12, so that's going to be 2 pi 12ths plus 3 pi 12ths, which is cosine of 5 pi 12ths. And that's your answer. They just wanted you to write it as as a single trig function, which means just a sine or just a cosine, and of one angle, not two angles like we had before. Sometimes we can evaluate it. This one we can't without a calculator. So this one they would not ask you to evaluate. That's your answer. And that's the end of this video.